Hello, good day viewers. In this tutorial, we are going to walk through all these 8 problems that are related to quadratic inequalities. But I think it is important to talk about some conditions. The first one is when you have an up and down parabola. Suppose we have y-axis as well as x-axis like this. An up and down parabola is something like this, right? And it happens that we have some roots a and b. Okay, let's start with the first condition here. If we have f of x, that is the function of this graph, to be greater than 0. Where do we have y to be greater than 0? It's only on these regions. You see, this is where y is greater than 0 because f of x is representing y. So our solution would be from a down to b, just within that region. So we have a less than x less than b. And if f of x is greater or equal to 0, you just need to change the inequality. It will be a less than or equal to x less than or equal to b. And you can also write it in an interval notation as x belongs to the set of values from a down to b, or you can write it as this one, that is x belongs to the set of values from a down to b. The only difference is what we use square bracket here while we use parentheses for just less than type. So this is the first condition. Then the second condition is when you have the function to be less than 0. So if the function is less than 0, you can see that this is exactly where you have y to be negative, because this is negative y-axis, right? So on these two legs, and you know that this is approaching infinity. So everything from negative infinity down to a, and anything from b way down to positive infinity. Therefore, the solution to this problem would be x less than a or x greater than b. You can see that all these values to the left hand side will be less than a, and all these values to the right hand side of b must be greater than b. So the solution will be in this form, and you can write it in an interval notation as x belongs to the set of values from negative infinity, because everything to the left hand side of a will approach negative infinity, way down to a. O is union from where? From b way down to positive infinity. And if the function is less than or equal to 0 this time around, the only difference is what? Less than or equal to. So we have x to be less than or equal to a, or x less than or equal to b. And you can write it in an interval notation as x belongs to a set of values from negative infinity way down to a, including a, union from b way down to positive infinity. So we are done with up and down parabola. Let us talk about up and up parabola. If we have y-axis like this and we have x-axis like this, an up and up parabola looks somehow like this, right? And suppose we have the roots to be a and b. So let's start with the function when it is greater than 0. Suppose this function is greater than 0. Where is y greater than 0? You know, on these legs, definitely everything above x-axis, because if you consider this, all y values here are negative. We are considering positive values of y. So you can see that the solution here would be x less than a or x greater than b, or in an interval notation as x belongs to the set of values from negative infinity down to a, union from b down to positive infinity. The same thing if it is greater or equal to, all you have to do is to include or equal to here, right? So in a case where we have the function to be less than 0, if f of x is less than 0, you know that this is where y is less than 0 between a down to b. So we say that the solution to this problem, x is from a down to b. If it is greater or equal to, less than or equal to, you use a less than or equal to x less than or equal to b, which you can also write in an interval notation as what? X belongs to the set of values from a down to b. So let's start going through these 8 problems.